In this video, we are going to describe a wireless system which we have built to enable voice communication in developing regions. Our system is called as Lo3 and it stands for low cost, low power and local voice. Lo3 is essentially a wireless mesh network using 802.15.4 or Zigbee technology. A wireless mesh network can be used to extend the coverage area using multiple hops between two endpoints, where an intermediate wireless node relays the data sent by the two endpoints. When operated on 1 mW of power with the help of an external antenna, the range of 802.15.4 node can be extended to about 500 meters. Thus, with the help of 10 to 20 nodes mounted on rooftops, Lo3 can cover entire village based over 2 to 3 square kilometers. We can then enable a real-time voice communication within the village between two handsets. We can also enable a remote call to and from the village to a phone in outside world by exploiting the cellular points of connectivity which are typically found within 2 to 3 kilometers away from the village. Lo3 is a low-cost technology since 802.15.4 enabled platforms cost order of just $50 and an 802.15.4 radio can operate in 2.4 GHz unlicensed band. Lo3 is also a low power technology since 802.15.4 platforms consume just 100 mW of power in comparison to 2 to 10 watts for Wi-Fi platforms or several kilowatts for cellular base stations. Thus, once powered on, an 802.15.4 node can last for several weeks without power off the grid. Thus, we believe Lo3 is an ideal choice to enable voice communication in developing regions. 802.15.4 platforms have been traditionally used for non-real-time embedded wireless sensing applications, and it was a challenge to enable real-time voice communication on such low computing platforms. In this work, we have built our own Lo3 handset which can sample, encode and transmit voice. We have also built Lo3 gateway node which can route the voice to and from the Lo3 network. And finally, we have built a lightweight media access control protocol to enable voice streaming. In Lo3, we enable local and remote voice using our custom-made handsets. The primary component of our handset is TI's low cost and low power C5515 platform. It has 100 MHz of DSP and 320 KB of RAM. To encode voice sampled by C5515 platform, we use Speaks encoder with data rate of 5.9 kbps. For user input and output, we have interfaced a 4-key matrix keypad and a 16:2 character LCD module to C5515 platform. We have also interfaced the 802.15.4 compliant CC2520 radio module. For our Lo3 gateway design, we have interfaced Simcom 900B based GSM modem to our C5515 platform over UART interface. To transfer voice between C5515 platform and GSM modem, we connect the line in and line out of our platform to the respective wires of RJ11 connector of the modem. When a user inside Lo3 network intends to contact a phone in outside world, he dials to Lo3 gateway node. The gateway node then asks for a number of the phone to be contacted. Now when a user in outside world intends to contact a Lo3 handset, an auto reply module asks the user to enter number of the Lo3 handset. This module records and detects DTMF tones and forwards the call to the appropriate Lo3 handset. We now describe our MAC protocol LIT, which makes it possible to stream real-time voice communication in Lo3 network. LIT is a multi-hop and multi-channel TDMA based MAC protocol. It uses a centralized architecture where a designated root node coordinates network activities like call admission control and call scheduling. Since LIT is a TDMA based protocol, time is divided into frames and each frame is further divided into slots. A frame repeats itself over time. A TDMA frame is comprised of 3 types of slots, and we will now explain working of these slots by a quick example. Suppose we have nodes R, A, B and C in our network. R is the root node. Suppose node D wants to join the network and have a call with node C. Node D first listens to control packets from node B and gets in sync with the Lo3 network. D then starts following the TDMA frame. It then sends a join request in contention slot towards the root node. Root node then admits D as part of the Lo3 network. Now D node sends a flow request to the root node. Root node then allocates a path between C and D and allocates resources on the path to enable the voice call. Once the communication is finished, C and D can send a tear down to the root node, and the root node then can deallocate the resource. We now show a quick demo of a voice communication in Lo3 network. In this network, we have two infrastructure nodes, which are the Delos P platforms and two handsets. Handset 12 is going to dial to handset 13. First, the user inputs the number of the destination handset and then presses the dial button. The root node allocates the resources and the call is established. Once the destination node picks up the call, the voice starts flowing between the two handsets. A user then can press a call tear down button to stop. We test deployed a full-fledged Lo3 network in a village near Mumbai, India for 18 hours over 3 days. Taking the effects of antenna height and link distance into account, we set up a 10-node network in the village. We attached 8 dBi external antenna to our nodes with RF cables and tied the antennas at a height of about 3 meters to plastic pipe using clamps. During our deployment, we observed that 802.15.4 links remained stable both indoors and outdoors, and they enable good quality voice calls. We enabled real-time voice calls with mean opinion score of 3.6, which is considered as good in practice. The villagers too gave us positive feedback. After our test deployment, the villagers themselves made several remote and voice calls. That such use was feasible without our intervention is a testimony to the system robustness and reliability. We now play a sample audio clip recorded at our handsets.
हॅलो नमस्कार. ठीक आहे. आणि सरपंच आहेत घरात का गेलेत कुठं? हां सरपंच आहेत का? सरपंच द्या ना त्यांच्याकडे. हां 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 येऊ द्या ना. हॅलो हां काय म्हणता साहेब? मग निघालेत का? निघालेत का नाही तिकडे लग्नाकडे? लग्न का निघालेत का नाही मांडवाला? काय कवा निघतो? लगीन उरकायचे अजून. हां 2 वाजते मग मांडव बिंडू जेवण. बरं आवाज येतो ना क्लिअर? हां साहेब हां रेकॉर्डिंग झाली तुमची. ऐकायची असेल तर यावरती.
Thus, in this video, we described our experiences of designing and deploying a wireless system in a village. We hope you enjoyed the video, and for any further references, please refer to following link and email address.